In lesson 4.4 cooldown, we're looking at another scenario where we have something that is growing exponentially, but the unit of time we're using is a little bit weird. In this case, we are told that, hey, this blogger started with 150 subscribers, and the number of subscribers has been doubling, but it's doubling every 6 months. So let's try to think about what's going on here. Our starting number is 150. And we're going to be multiplying that by 2, because we're doubling it. But we're not multiplying by 2 every month, because that would mean that after 1 month it doubled, and after 2 months it doubled again, but they tell us it's every 6 months. So what that means is I have to take whatever number of months it has been and divide that by 6. Because now, for example, if I plug in, hey, it's been 6 months, well, 6 months divided by 6 will give me 1. In other words, it has doubled once. And if it's been 12 months, 12 divided by 6 will give me 2. It's doubled twice. So you can kind of see where this is going. So using this, now the question they're asking us in this problem is, by what factor is the number of subscribers increasing every month? So we don't care where we started, really. All we care about is, hey, after 1 month, what am I multiplying by? So we can just find 2 to the 1/6 power. Technically speaking, that's a perfectly fine answer right there, 2 to the 1/6, but I'm kind of interested in what that number actually is. So I'm going to go and do 2 raised to the 1/6 on my calculator, and that's going to give me 1.122. So there is my growth factor for 1 month, whereas 2 is my growth factor for 6 months. Now, in case you don't really like using the fraction in your calculator when you're trying to find this number, remember you can always do 1/6 first, find what that number is, which is 0.1666, and so on. And then you can use that in your calculator if you don't want to use the fraction. The second problem here now wants us to just take this math we just started working with and say, hey, what other ways could we write that expression? So if we look at option A, this problem isn't going to work. Because what is this doing? This is doubling every month, which we know is not what's supposed to happen. It's supposed to double every 6 months. Okay. The second one, well, this is weird. This is not exponential at all. This is actually quadratic, because we have the variable being squared. So this one's also no good. When we get to the third one, this is where we start to see something that makes sense, because this is actually the one that we found. Right? We wrote this right up here. The fourth one, this is a little bit interesting. So what they are saying here is that instead of dividing the number of months by 6, like we did in part C, we're going to divide the growth rate by 6. Now, we can test this really quickly by just saying, hey, what happens after 6 months? In option C, after 6 months, it doubles 1 time, so we get out 300 as an answer. In this one, after 6 months, let's do the math. We're going to do 150 times 2 divided by 6 to the 6. And we can put that in our calculator, parentheses and all. And that is going to give us a really strange looking number here. That's going to be 0.206. So something really went wrong here. And you may have already spotted this. That's not a highlighter. This number right here is smaller than 1. So this is actually showing us decay, not growth. So that's not going to work. Don't try to change your growth rate try to change your exponent when you have these weird timing problems. So the last problem, option E, this one again looks a little funny, but you can test this for yourself. If you plug in 6 for m, this will actually work. So if you do 150 times 2 to the 1/6 to the 6th, you will get 300, like you should. You should double one time. But in general, we don't always want to have to test our equations. We want to kind of know if they'll work ahead of time. In general, there's kind of a trick here. I can show you real quick for exponents. If you have an exponent raised to another exponent, you can multiply them. And if you multiply those exponents, you'll end up with just m over 6, which is exactly what we had in option C. So option E does work here as well. Some of those are a little bit tricky, but there are 2 there that are correct.